I'd now like to present my equation for the best equation. So this first term represents the sum of the component terms of the original equation itself, obviously. Then you have the second term, which represents the geometric product of the different dimensional constants that feature within those terms themselves. Now, as you'd expect. Now, there's a factor there that you multiply where you take the exponent of the ratio of the number of dimensions featured in the equation divided by the number of derivatives that appear in the equation. All of that, of course, is multiplied by I pi, just so that you're in the complex Argand plane of excellence. Now, what is implicit in all of this, of course, is that you've actually got a Hilbert space representing each one of the terms, so they're mapped against one another. And then you take the dot product of that with the fundamental tenets of magnificence. So they're represented by the I and J indices there at the bottom. But then once you sum over all of those, then, of course, you start to get into the real meat, which is, of course, the bestness of the equation itself. Now, there are a few corrective factors that you can add there as well, where you take into account things like the fundamental constants of nature that appear, the number of irrational numbers like e and pi that feature as well, but also, you know, you've got things like frivolity of terms. So you sometimes get these equations that will have things like wonderfulness or magnificence, and sometimes they can get bonus points for just being a bit of fun, really. But yes, I think taking all of that and, you know, multiplying by -1, that gives you your equation for the best equation.